Okay, this is problem 1 from the Chapter 7 review. In this problem, please change the denominator to cosecant of theta. There was a typo on that particular problem. Okay, so in this problem, you cannot replace cosine with anything, but you can replace cotangent with cosine over sine. The denominator can be replaced with 1 over sine. The top then becomes cosine squared over sine. Float and flip the denominator up to the top so that you're multiplying by the reciprocal. At that point, sine cancels. Final answer, cosine squared. Number 2. Number 2, you are trying to prove whether this is an identity or not. This is the original problem. Parentheses on the right-hand side indicate that you should possibly try to FOIL. So I'm going to try that to see what I get. These are conjugates, so you can FOIL by the square minus square shortcut. Okay, so you can be looking at either the first parenthesis or the second one. Just square the first term, which is 1. Square the second term, which is cosine squared, and drop a minus in between them as the shortcut indicates. Now, at this point, I would refer to the Pythagorean identities, one of those being sine squared plus cosine squared is equal to 1. And if you do a transformation of this Pythagorean identity by bringing the cosine squared to the other side, it becomes 1 minus cosine squared is equal to sine squared. That means sine squared is equivalent to this expression. So whenever you see this expression, you can replace it with sine squared, which is the next thing I'm going to do. On my right-hand side, I have 1 minus cosine squared. Replacing it with sine squared, drop down the sine squared on the left side, and you have proved that both sides are equal. With the identity, make sure that you are not moving things from side to side in the original equation. That's one of the steps that's not allowed, and you are to keep working the possible identity all the way into the point where you get both sides to be equal. Okay, problem number 3. This one is a simplify the expression. I have a tan x on the outside with a cosecant x minus cosine x minus secant x. I'm going to try distributing. So I'm going to do tan of x times cosecant of x, and then tan of x times cosine of x minus the secant of x that was on the outside of the parenthesis. Now I'm going to start replacing anything that has an alternative definition. Sine of x over cosine of x represents tan. Another definition for cosecant is 1 over 1 over sine minus Again, sine over x times cosine over x for tan times the multiplier that's next to it, cosine of x, minus secant of x. I'm going to leave this secant the way it is right now and then decide whether I need to rename it in the next step. Here I have several things canceling. Sine of x cancels, and I have 1 over cosine. Then here I have cosine canceling with cosine, which is sine over x, and a negative secant of x all the way on the right-hand side. 1 over cosine can be called secant of x. So it turns out that my first and third term cancel, leaving me with just negative sine over x as my final simplified answer. Okay, problem number 4. Okay, problem number 4. Use an appropriate identity to find the exact value of the expression. Okay, I think the first thing I'm going to do, just to bring you into more familiar territory, is to change the 11 pi over 12, the radian type angle, into degrees. So I'm replacing the pi with 180, dividing by 12. Put that in your calculator. 11 times 180 divided by 12. And you get 165. Okay, next thing you're going to do is try to split up the 165 so that you are using angles that you are familiar with, such as 30, 60, 45, or any of the quadrantal angles. I'm going to split this up into, since it ends in 5, I think one of my angles is going to be 45. And the other one will be 120. 120 is a good angle, even though it's not a 30, 60, or a 45. When you spin to 120, you're going to have a 60-degree reference angle. So just being that it's related to 60 degrees is the same as doing a 60-degree reference angle. So now I'm going to use the formula for the summation of two angles in the cosine. That formula is one of the homogeneous pairs. It goes cosine, cosine as a product. And then sine, sine. Now with the cosine formulas, the sign that you see here, it's the opposite in the expansion. So we have a homogeneous product in the front, a homogeneous product in the back. Okay. Now what you're going to need is to know the numbers for cosine at 120 and the sine at 45 so that you can create the fractions that represent the sine and the cosine at those angles. So you either have them memorized or you can draw a picture. I'm going to draw my pictures off to the side. At 120, I would be right here. If you rotate 120 degrees, that means you have 60 degrees right here as your reference angle. That would mean this is the long leg, this is the short leg, this is the hypotenuse. Then, again, you either have the numbers memorized for 45 or draw it. For most of you, it's probably going to be a good idea to provide yourself with a visual. So this is 45. And for that, we used legs of 1. hypotenuse, square root of 2. Okay, so now looking at these triangles, as I plug in for each of these values, I'm using x over r for cosine, and anytime I see sine, I'll be using y over r. Okay, so the cosine off of the 120 degree triangle, one with reference angle of 60, would be -1 over 2 for the cosine. That's x over r. Then for cosine of 45, again, x over r, but off the 45 degree picture. So it's going to be x over r. Then do the sine products. So sine at 120 would be y over r. So that's square root of 3 over 2. Multiplied by sine at 45, again, y over r would be 1 over square root of 2. Both of these denominators are 2 square roots of 2. That's when you multiply the front product as well as the back product. You have a denominator of 2 square roots of 2. So I'm going to bring this into one fraction. Top of the first product is -1. Top of the second product is minus square root of 3. And then the only thing you have left to do here is to rationalize. Multiply the bottom by the square root of 2 as well as the top. You're going to have to distribute the square root of 2 to both terms in the top, which is going to leave you with negative square root of 2 minus square root of 6 over 2 times 2, 4 on the bottom. Okay, that completes problem number 4.